Start recording. Okay, so today, I just lost my train of thought. Okay, well, at least I have this reference here. Okay, today, oh yes, I hope you guys had a good weekend. You know, you had Monday off, and so I hope that was nice, and welcome back. And you know, we're still in online school. But yeah, week 3, happy Wednesday. Today's lecture, we will talk about importing and exporting data in R, and we'll also introduce web scraping, and I'll have a little demo of kind of using tools to scrape the internet. Okay, so let's talk about just importing data, and I think everybody has used read.csv at some point. And interacting with R to get your data into R. But these are kind of your other basic commands. There's read line and read.table for, you know, read line will basically prompt the user for input from the terminal or the console. Read.table is for basically just any kind of file. And the default behavior was strings as factors true. I think they've changed this default behavior to be strings as factors equals false, which is nice. It used to take all kind of character input and turn it into factors, which occasionally was very annoying if you had character data that wasn't representing a categorical variable. There's a bunch of other packages that are part of the tidyverse, and let me clear everything out of here. Part of the tidyverse. So you have readr, readxl, haven. These are all part of the tidyverse. And then there's another package, data.table. Now, if you don't have any of these installed, you might have to install these. Install that package is readr, install that package is readxl. And actually, you know, what I should just write is install that package is tidyverse. And that's going to probably load up, install all of these things for you. It takes a moment to do. And I really like the tidyverse. There's a little bit of overhead, right? Like in order to use any of these things, let me kind of just restart my session. In order to use any of these things, like if you wanted to do anything with read.csv, it's going to say not found. If you want to do read_csv, you have to do library tidyverse. And that takes a moment, all right? It takes a moment to load, but then you can use read_csv, right? And that now loads, and it's an excellent thing, but you've got to load up the tidyverse. And so if you don't want the overhead, you can just use read.csv, but read_csv from the tidyverse is great. Okay, so readr is for kind of your general plain text files. If you need to read in an Excel file, you read Excel. If you've got other stat software, Stata, SPSS, whatever, you can use Haven. And then there's another package, not part of the tidyverse, but it's called data.table. And it's an incredibly good package for loading big files, okay? So with package reader, and package reader is already incorporated into RStudio. When you use RStudio and you use import data set, you can just use the point click interface and use from text readr, and it's going to do that. You can also use base, which will do read.csv. I recommend the readr. It's going to be it's going to be faster and better. But sometimes you need to write a script rather than telling somebody, you know, click here and click here. You want to write a script so they can load up the data as part of the script. And if you're going to do that, you know, you can do read_CSV, and then you got read_ all of these other things, fixed width files, delimited files, all kinds of different kinds of files. But probably your most common one will be your CSV one. So the difference between read_CSV and read.csv is read_CSV is part of the reader package, part of the tidyverse, and it gives you better performance. But again, it costs with the overhead of having to load up the tidyverse in the first place, which, you know, takes a moment. There's also data.table. This one's even faster than read_CSV, but really you only get to appreciate the difference in speed once your files get really, really big, because read_CSV is fast. Not as fast as fread, but it's fast enough for most of your day-to-day use. It's only if you're loading like a file that's like 1 GB big, okay, or something very big. So I don't know if you're going to participate in DataFest this year. When signups go up, but I encourage you guys to try out, try participating in DataFest. And on occasion, the data sets you get in DataFest are these massive files. Okay, not always, right? Sometimes a data set doesn't have to be huge in order for it to be interesting. You can have a smaller data set and it can still be very interesting. So DataFest, they always try to find interesting data sets, and sometimes they're big and sometimes they're not. If you do have a big one, and we're talking something over a gigabyte, something over a few 100,000 lines of data, fread might be a better choice. But if you're under 100,000 lines, read_CSV is probably going to be good enough, right? You got 60,000 lines. That's still a big data set. Read_CSV probably fine. Okay. But anyway, fread and read_CSV are similar. Read_CSV is about half the speed, but it's a little bit more complicated. It has a different underlying structure, but read_CSV good enough for most situations. If you're dealing with Excel worksheets, which is pretty common in the workplace, your boss, your manager might give you an Excel worksheet, and then you want to do some analysis in R. Well, you have a few options. You can like export from the Excel into a CSV file, or you can just use read Excel, and you can read in the those Excel worksheets directly, right? Things get complicated because sometimes people will do like formatting on an Excel sheet, and they'll take a certain thing and then they'll like try to draw pictures inside Excel, and that's different. fread is not from the tidyverse. fread is from data.table, which is not from the tidyverse, but they play pretty nicely with each other. Okay. Anyway, reading Excel, Excel worksheets, workbooks technically have multiple sheets, and you can specify which sheet you want by specifying the name of the sheet or which number of the sheet. Sometimes you want to get data from the internet, okay? And so here in my GitHub, I have just a CSV file, and so let me copy the link there, and we'll go there. And here's just a CSV file, right? And you could do save as and save the CSV file somewhere onto your computer, okay? But you can also just take this address and copy it and load it into R. Now R has a native thing called download.file, and it will download things. But this download.file was made, back in the 90s, early 2000s, internet, where you didn't have like, you'd use the HTTP protocol, right? Hypertext Transfer Protocol, which versus the secure one. And today, almost every single website uses HTTPS, and there's kind of this, you have certificates, and your browser has to authenticate these things in order to establish a secure connection so that you can't have people, eavesdropping on, what pages you're visiting and what information you're getting from a website. And so download.file runs into problems over HTTPS, okay? So instead, I recommend using this library called Downloader. So you might have to install this. You do library downloader, and this handles the secure websites, which is pretty much all modern websites today, right? And so now you can just go to download. You give it the URL as a string, and then you say, I want to download it to this file, and you give the name of the file as a string, iris.csv. Now you have to establish your working directory, and it will download to your working directory. And then once you've downloaded it, then you can read it from your working directory using read_CSV, right? So you download it somewhere to your working directory, and then you load it up using read_CSV, and that works. On CampusWire, by the way, you guys are doing a great job on CampusWire, and so thank you to everybody who is participating on CampusWire and responding to questions and things like that. I do see the occasional question posted, and sometimes the solution is, making sure you set your working directory correctly. And I know if you're not used to organizing all of your files on your computer, and being cognizant of where your working directories are and things like that, it can feel a little bit strange. But if you kind of compartmentalize all of each project, each homework assignment, each thing, and kind of its own separate directory, and you get in this practice of setting each of the working directory to each thing separately, I think that's a good habit. Another thing I want to say about CampusWire is sometimes you ask a question and then you get the response back, and then you're like embarrassed by your question because maybe the response was, the answer is like so simple, and you feel like, oh, how could I have not seen that answer, or how could I have not known that, right? Sometimes you get embarrassed when the answer comes back, and then you're tempted to delete that question, and I understand, right? Like the embarrassment that comes with that, but I want to encourage you not to do that because I don't know how the CampusWire scoring works. And so if somebody took the time to answer your question and it actually answers your question, you should give them an upvote so that they get the points that that they want and need, rather than deleting it. And because I don't know what happens if you delete a question, if the person who responded loses their points and things like that. So anyway, and chances are you got multiple classmates who had the same question, and they just didn't want to ask or something. So that could happen. I want the CampusWire to be kind of a friendly zone where you don't have to feel too embarrassed about asking your question. Whereas places like Stack Exchange, they're a little bit stricter on the questions, right? If you ask a quote unquote bad question, they'll delete your question and stuff like that. And this is just our class thing. It's obviously if somebody's trolling, and I don't think anybody's trolling here, and I've turned off anonymity for that exact reason, because the first time I used something like I used like a Piazza forum, and I think in Piazza you cannot turn off anonymity. I don't know, maybe they've changed it now, but some people were like mean, and I was like, that's no good. So in this class, you have to use your name, and I think that helps stop people from being super mean and things like that. But anyway, you guys have been great. I think a lot of supportive and helpful questions and answers. So thank you guys. Sometimes you're working, right? And it took you a long time. You had to do a bunch of computations. You finally got the matrix you want, right? And I've always encouraged you not to save your workspace and not to load your workspace when you exit. So what do? You can just save your, not to workspace on X, save your workspace on exit. You can save your workspace explicitly. You can always kind of click in the environment. Here's the little save icon. I was talking to somebody, and this save icon, do you guys know what it is? It's a floppy disk. And I don't know if you've ever seen a floppy disk in real life, okay? This is storage. Like there was no internet, you couldn't email people stuff. And so if you wanted to give somebody a file, you had to save it onto this little plastic thing that goes into your computer. And then when you insert it into your computer, it made this noise. It is like this magnet was reading and writing stuff, and it was so slow. It's kind of like a flash drive, except it was way worse than a flash drive. It was literally a thin, flimsy piece of plastic that was magnetic, and inside this thing of, I don't know if I could even find a floppy disk drive these days. And you just look up floppy disk drive online, and you'd be amazed at how terrible the technology was. And, and you would put it in there, You could store a whopping 1.44 megabytes. You had anything bigger than that, it wasn't going to work. And so compression technology was very important back in the day. And you would put this. So anyway, this is a picture of what a floppy disk looked like. And you know, if you download it, if you purchased a game at the store, it comes in a big box, and there would be like 7 of these floppy disks in there. And this was like a big game. It was like a 10 megabyte game, and you had to load every 10, all 7 of these floppy disks. And you know, you had to get special storage containers for them to keep them safe and shielded from magnets. Somebody brought a magnet near your floppy disks, you'd lose all of your information. It's kind of like a flash drive, but just way anyway. And then somebody came out with the 100 megabyte floppy disk, the zip disk. That was amazing. And that, you know, but anyway, all right. What was I saying? So you can save it, but if you want to just save individual objects, you can save them right here. If you want to write like a data frame, you can do you can take your data frame and write it to a CSV file. By default, it saves the row names, and you probably want to do row names equals false. Okay. If you also want to just save a big vector, you can just take your vector X and save it to some text file as well. Oh, handling dates. I feel this lecture makes me feel like the grandpa who's like, back in my day, we had to walk uphill in the snow and things like that. So when working with dates in R used to be this very painful thing, right? So here is a date, January 15, 1999. And to get this read into R, you had to say, oh, January, by the way, is written out as the full name. And that used to have R recognize that it was %B. And then day was written here. And then the year is written in 4 digits. And there's a comma after the 15. So you had to format this, and they would recognize, oh, that's the date, 1999, January 15th. But if you make a small mistake in your format, here I've left out the comma. I forgot there was a comma between here. R freaks out and says, oh, I can't do it. I can't do it, okay? Here's another date, December 15th, 2001, okay? And we say this is month dash day dash year, okay? There's dashes. And it recognizes, again, if you leave out the dashes, it freaks out and can't do it, okay? And then, and if you had a string where people had entered their dates in slightly different formats, R was not able to handle this, okay? If you say, all right, I've got the date in this format, it recognizes the first one, but not the other 2. You say, okay, well, I've got the dates with the dashes here, month, day, dash, year. It recognizes the middle one, but not the other 2. Or if here I got month slash day slash year, it recognizes the last one. It doesn't recognize the other ones, okay? Oh, question. Is date, like someone's birthday, is that a numeric variable or a categorical variable? What do you guys think? All right, so everybody's writing categorical. Everyone's categorical. It's actually a numeric variable. It's actually, date is a numeric variable, right? So how does this work, right? Because how can the date, right? January 22nd, January 19th, 2022. How could it be a numeric variable, right? And February, right? How can these be numeric? Okay, dates, we just have this weird system for keeping track of time. And everybody just agreed to it. And we said, all right, this is how we're going to do it. 7 days in the week. Who decided that, right? And we just said, hey, you know what? Let's say year 0 is going to be based on, you know, the important religious figure. And we're going to establish year 0 there. And everybody just said, okay, I guess. All right. And then months. Oh, you know what? I'm Julius Caesar and I want a month named after me. And I'm Augustus Caesar and I want a month named after me. Okay, you're in control, so we'll do it. And then we just kind of established, you know, names for months, and and things like that. And so if you think about it, what makes a numeric variable numeric is that you can make comparisons, right? You can say one person is 10 inches taller than another person. One person is 5 pounds heavier than another person. And with dates, you can say one person is 1 year older, or you can say they're 365 days older. One person is 18 days older. Because you can make these numeric comparisons, it's got to be a numeric variable. And all we've done is we've just said, you know, January 1 in the year 1, okay, that's going to be our starting point. And, you know, 365 days after that would be January 1 in the year 2 and things like that. And we've kind of established this. And so inside a computer, if I do as.date and inside the computer, if I do January 19th, 2022, and the format is, what is this? %m/%d/%Y. Okay, so this is this, and I can do as.numeric. And this converts the date into a numeric value. And this is technically, it's been 19,011 days since January 1, 1970. Alexa, what is 19,011 days after January 1st, 1970? I don't know if you heard her say that, but she says this is the date. And so if you do as.numeric January 1, this is the 0 date and for a computer. January 1, 1970 is day 0. Okay, January 2, 1970 is 1. Okay, if you do January 1, 1971, that's 365 days. January 1, 1972, 730 days. And it's got leap years built in. So if you go to 1973, it's going to say 1096 rather than 1095. It's got, you know, all of these dates built in. And so you can kind of establish, right, if we go January 19th, 2022, we can take the difference between 2 days, right? So I can say, what is the difference between January 19th, 2022 and say October 1st, 2021? And it's going to say that there's 110 days between October 1st, 2021 and January 19, 2022. It's just on the computer, we've established January 1st, 1970 as the 0 day. And that's that. There is a, is it 2 to the something. Okay, one of these days we're going to run into a problem with our dates. I forget where the integers that we use to store how many days it's been since January 1st, 1970 runs into a problem. I think it was, I don't remember when it was, but anyway. So date is numeric. It's just, we have just a weird convention of saying like, okay, this is how many days have passed since this arbitrary point in time. So anyway, yeah, Y2K was kind of a thing where the last 2 digits of the year was stored as, you know, 99. And then, you know, what happened when it went to 00 and it became 1900. There's kind of another thing, I can't remember what it's called, but it's basically the storage for how many days it's been since January 1st, 1970 runs into an integer problem. And basically old computers might not be able to represent it. Okay, that was beside the fact. Okay, but anyway, with Lubridate, this makes it all easy. You got different formats here. All you have to do is say, hey, month, day, year, and it recognizes all 3. It recognizes all 3. So if you're dealing with dates, don't try to do as.date. This is so frustrating and painful. Okay, you can only work with one format at a time. You get different dates coming in as strings. Just say, hey, Lubridate. Okay, it's like lubricating your engine with oil. And this is a play on the words there, right? You're lubricating it, working with dates here. to make it run smoothly. Month, day, year, it makes handling this easier. Okay. If you have something ambiguous, 03, 04, 05, thank you for those friendly reminders for the view quiz. What was the view quiz answer for today? Okay, I'll give you your first two. The first two answers are D and A. D as in dog, A as in apple. D as in dog, A as in apple. Okay, D as in dog, A as in apple for the first two view quiz answers. We are going to, so if you have ambiguous dates, you got to specify year, month, day will be, if this is year, month, day, that's a different day. That's, 2003, April 5th, month, day, year. This is March 4th, 2005, day, month, year would be the 3rd of April, 2005, right? So these are all different things. And if you give it something wrong, right here, I got like December 25th, 1999, this isn't going to work because here I'm saying it's month, day, and it says there's no 25th month. There's no 25th month. Okay, so it fails to parse. Okay, let me show you rvest. Rvest is kind of a play on words for harvesting. We're harvesting data, but we're using R, so it's rvest. So we're scraping. We're doing web scraping here. And in order to get it to work, we have to use something called Selector Gadget. Okay, Selector Gadget, and I will show how this works. Are all of these packages installed when you install Tidyverse? Tidyverse installs a lot of things like Lubridate and Reader and stuff. I don't know if it installs rvest right off the top. I'm not sure. So you might have to do install that package as rvest. I don't remember. So if you get an error, just install that package. Okay, so one thing about rvest. rvest is great for basic web scraping, okay? And what I mean by that is, a lot of modern pages these days implement infinite scroll because it's addictive. And so rvest doesn't work well on pages with infinite scroll. Okay, it's going to work well with static pages. So a static page is going to be something where like you load it onto your browser and then it's done. And if you scroll, the content's not going to change and things like that. It works well with well-defined HTML pages. It's not going to work if it's got dynamic content constantly changing, right? Like infinite scroll. And it's also not going to work if you have to log in to view content. So if you had to do something like if you wanted to try to scrape data from Facebook, which by the way is against its terms and conditions, but if you wanted to do that, it's not going to work, right? Because first you got to log in to see anything, and then it's got infinite scroll, so that that's going to break things. So it's not going to work well there. Any kind of stuff where you have to log in. So an example where it could work. So you go to old Reddit. Old Reddit will have the static pages where if you want to see more content, you have to click next. Versus, the newer Reddit, it just has kind of infinite scroll that just kind of, as you keep reaching the bottom of the page, you can't reach the bottom of the page because it keeps loading new stuff, right? So, but anyway, when you go on a page, okay, so here on the Lego Movie page, what it's doing, you can always go to inspect, right click, and you inspect it. There's all of these HTML tags and CSS, and I don't know if anybody's taken a class on like web programming, but we control formatting of a web page using CSS. Okay, and the formatting is done consistently using these CSS tags. And here's kind of a simplified version of what maybe a list might look like in on a web page. And all of these things are going to have little classes, and it will tell you how to kind of designate how this stuff is going to work. Okay, and we use these tags to select or format or control how a web page will look. And so what Selector Gadget does is it reads through these tags and it picks out the HTML. Okay, so how do you use Selector Gadget? Okay, first you go to selectorgadget.com, or you can just search the internet for Selector Gadget. There's a Chrome browser extension. That's a newer thing. Or you can just go to selectorgadget.com, which is what I've done. Okay. So if you go to selectorgadget.com, there is this thing. It says drag this link to your bookmark bar. So if you're on Chrome or a lot of browsers, you can hit Command-Shift-B to show or hide your bookmark bar. Okay. So here I'm showing it and here I'm hiding it. You can always kind of go to the menu and do, oh, I don't know. Bookmark bar. Okay, show bookmarks bar. Okay, and here I drag the selector gadget to the bookmark bar. Now I already have it up there. Okay, but you can just click and drag this to your bookmarks bar. All right, and that will establish the selector gadget. Okay, so let me just show you how this is going to work. Okay, so let me come over to here, and I'm going to load up rvest. Okay, so you do library rvest. I'm going to do library stringer. I don't think I actually need library data table, but anyway. What I'm going to do is I want to extract information off of the Lego movie page. So I've done this selector gadget business. And here is the web page of the Lego movie. Okay, so here's the Lego movie. And so I put this in here. And I tell rvest and I say, read the HTML of this web page. So I do read HTML and I give it the URL for the web page. And I'm going to store it for Lego movie page. Okay, right here, Lego movie. And so I do that. Lego movie is now stored the HTML content of this page. So basically, if I right click and I do view page source, there's all of this code, okay? And R has read all of this in, and it's storing it inside Lego movie. All right, but we're not going to use the original source. We're going to kind of work with this. And from this, let's say we want to extract some information. So let's just say we want to extract out the IMDb movie rating. Okay, here it's 7.7 out of 10. 7.7 out of 10. So what I'm going to do is I'm going to click Selector Gadget. Okay, and I click Selector Gadget and it loads, it puts this little box here. And now when I move my mouse around the page, we see these orange bars or, orange borders float around everything that I'm hovering over. I'm going to hover over the number that I want. I want to extract out this number, 7.7. So I'm going to click this, okay? And when I click this little thing shows up here, .itlwov. Okay, I'm going to go ahead and it says clear, and there's a 2 in parentheses saying there's 2 items here. And when I kind of look around, I don't see anything else in green or yellow. So I go, okay, that's fine. I'm going to click this and just copy that. This is the tag. This is the CSS tag being used to identify this one item on the web page. So I copy that. I'm going to X out of the selector gadget, right? And so now it just works regular. I don't get those orange boxes. And I'm going to paste that HTML tag into this thing for HTML nodes. So I put quotes, HTML nodes. Okay. Now I'm using pipes. Okay. I'm using pipes, and I don't know if you are familiar with pipes. And so the way this works is, remember, I have the the code for the web page stored in Lego Movie. And normally, if you want to extract out HTML nodes, you'd use HTML nodes, and then you put in the that code, Lego Movie, and then you give it the tag that you want to extract, okay? The ITLWOV tag, okay? And when we do this, it's going to extract out those HTML tags, okay? And normally inside R, you take your thing, and if we wanted to do something with this, I would nest this output inside another function. So I could take this previous function and I can nest it inside another function. And this time I want to extract out the text from these HTML tags. Okay, so I'm going to put the result of HTML nodes inside the function HTML text. Okay, and when I do that, it extracts out 7.7, and we have this here. And then if I want to convert this to a number so I can work with it, I'm going to take that output and I'm going to nest that inside the function as.numeric. And I think we're familiar, right? We're okay with this idea of taking one thing, nesting it inside another thing, and nesting it inside another thing, right? Where we can take, one function and apply another function to it, and take that result and apply another function to it. And we're nesting the content inside each other, okay? So I've got the Lego movie inside the HTML nodes, inside the HTML text function, inside the as.numeric function, okay? Is that okay, what's happening here? Now, what pipes do, all right, and this is fine, and this works, but it's also a little bit hard to read because we're accustomed to reading left to right, top to bottom, and the process that it's going, in order to read this correctly, you have to start on the inside and work your way outwards, right? So it's a little bit hard it's a little harder for us to read it, okay? And so what pipes do is it kind of takes the reading and it puts it in a format that we're accustomed to, left to right, top to bottom. So this is exactly equivalent. We're gonna take Lego movie and take the Lego movie and put it inside the function HTML nodes. And then we're going to take the output of HTML nodes and put it inside the function HTML text. We're going to take the output of HTML text and pipe it into the function as.numeric. So this command with all of the pipes is exactly equivalent to this command. And so when I get so these two commands, as.numeric with all of these things nested inside, is exactly equal to this, okay? Now, when you use pipes, you're going to use more lines because instead of nesting things and going wide, you're going to turn them into kind of this, like a list of steps, okay? And in my opinion, this is easier to read than this, okay? Now, you might have different opinions about this, but in my opinion, it's easier to read this because it feels very much like a list of steps. First do this, then do this, then do this, and then do this. And every time you're taking the output of the previous step and putting it into the next step. Okay, does that kind of make sense what's happening here? As far as using the pipes. And so that's, so I'm going to be using pipes throughout the rest of this script here, but it's equivalent of taking things and nesting them inside of other functions. It's just, for me, it's easier to read the steps rather than the nested thing, okay? All right, and so anyway, by using that tag that was associated with the 7.7, again, using the selector gadget, which I loaded from the other page, and I selected this and I got this tag. By using that, I'm able to extract that piece of information. Okay, let's say we want to get more things, right? So here again, I have the selector gadget. I'm going to click it. It's going to load this little thing. And let's say I want to select the cast members, right? The actors in the movie. So I click Chris Pratt. And when I click Chris Pratt, this turns green. And everything else with the same tag shows up in yellow, okay? So this tag is EZTGKS, okay? Whatever that means. But this is the tag that shows up in the code. And the other actors in this movie have the same tag, okay? And it says 18 inside parentheses. So that means 18 items will be selected when I select this. And that seems reasonable. So I'm gonna go ahead and I'm gonna copy this, this tag. I'm gonna exit out of here. And then I'm gonna take Lego movies. I'm gonna say, give me all of the nodes with that tag, EZTGKS, okay? And then extract out the text, extract out the HTML text. So again, nodes takes the full, takes the full HTML data. Here, I just want the text associated with it. And I'm going to store that into cast. And so when I do cast, we get the names, okay? A vector of 18 names with all the names from the page. Chris Pratt, Will Ferrell, Elizabeth Banks, Will Arnett, Craig Berry, et cetera, et cetera, et cetera. Okay, well, great. So it's question, is it just giving you the class name associated with the text? Yeah, so when you use Selector Gadget, it's just when you click on a piece of text, it will tell you what it either the class or some kind of identifier. And so, yeah, right now in the CSS, the class name of this thing is EasyTGKS for whatever reason. That's the thing. Okay. Now, sometimes the piece of information you want is hard to get. Okay. And you have to kind of play around with Selector Gadget to select things you want and unselect things you don't want. So here I'm going to load up Selector Gadget. And let's say I want to extract out this review. Okay. This is a user review. And this is someone's opinion. So here I want to extract out this text. So I'm going to hover over this and I select it and the text turns green. That's a good sign. But look here, the tag being selected is a div tag, which is pretty much every single thing on the web page is also going to be inside a div tag. And so there's a whole bunch of other stuff. 981 things are going to be selected. I don't want that many things. So I'm going to just come up here. I'm going to say, you know what? I don't want any of this stuff here. So I'm going to just click over here. And when I click over there, okay, that turns red. All that stuff that used to be yellow now also is no longer yellow. And it says you're going to be selecting 9 things. And I say, you know what? Really, I just want this thing. I don't want all of this other stuff. All this other stuff is in yellow. So I'm going to just click over here. And I click that. And it says 6 things are going to be selected, right? And so I scroll around. I'm looking for, it's a little bit of a hunt. So we say, oh, this is in yellow. I don't actually want this, all right? I don't want this in yellow either. So I'm going to click that. And now it says 3 things are going to be selected. And it looks like this part's yellow, so I'm going to click that. And so finally, after I click that, only 1 thing is in green. Only 1 thing is going to be selected. And so the tags that I need to use to specify this exact one piece of information is a whole bunch of tags. It's a lot of stuff, but I'm going to highlight it, copy it, X out of here. And I think the tag is all of this stuff: IPC overflow text list card.ipc overflow text log, et cetera, et cetera, et cetera. That's the tag, the CSS selector, okay, or CSS class or whatever it is. And we're going to run the same thing. Lego movie, select the node. There's really just one node with this, and extract out the text. Okay, store that as the review. And so now when I look at the review, you know what? It loaded a different, I think when I refresh the page, it's going to load a different review here. Okay, so yeah, so this is, okay. So here's the review. The standout feature of the Lego movie for me would be the way the Lego universe was created. Okay, and that is the review being extracted out here. Okay, and so yeah, it looks like the IMDb kind of just randomly selects a review here, or maybe selects there's some algorithm for selecting what review gets featured here, and it seems like it changes every maybe a couple hours or something. It still has the same HTML tags, but and so it ends up selecting this thing. Okay. All right. Boy, I'm going to run out of time, but let me give you your last view quiz answer. Today's last view quiz answer is the letter B. B as in bear. B as in bear. But I really, really want to show you the next thing, and it's important. Okay. So what we want to do is, let's say we want to start at the Lego movie, and we want to go to each of these actors' pages. So I'm going to just delete close these other windows. And let's say we want to go to Chris Pratt's page and see what movies Chris Pratt is in. Okay, right? This is kind of always fun on IMDb. And then you click another actor, Will Ferrell. Let's go to his page and see what movies Will Ferrell is in, or what TV shows or projects they're in. Okay. Let's go to the next, Elizabeth Banks. Let's go to her page and see what kind of projects and stuff they're in. Okay, or she's in. And we're going to do that. Okay. And so where do we get the name of the projects? Okay. Again, I'm going to use Selector Gadget. I'm going to click and hover over the piece of information I want. I'm going to select Cowboy Ninja Viking. Apparently that's being produced here. And that highlights a whole bunch of stuff, a little bit too much. So I don't really want all of that. So I'm going to select something I don't want. I don't really want the episode names. Okay, but when I do that, now hardly anything is selected. So I'm going to come back and I'm going to say, you know, I do want like Garfield. And it looks, I scroll through all of these things that are in yellow that are being going to be selected, and that looks about right. So it looks like the tags I'm going to use are B and A. Okay, BA, those are the tags. And if I go to Will Ferrell's page, same kind of thing, using Selector Gadget. If I select this and I say I don't want this, but I do want this, okay, also the same tags, BA. So that's a nice thing across all of these different pages on this site. As far as the actor and their projects that they're working on, they all have the same tags, B and A, and that's going to be helpful. So what we can do is we can go to that particular actor's page, Chris Pratt's page, read the HTML from that page, select the nodes, BA, and select the text, right? And so if I do that, this will list off the projects that Chris Pratt is working on, which, you know, this is straight from their web page. We've got Cowboy Ninja Viking, Garfield, Untitled Illumination Entertainment Project, Guardians of the Galaxy Volume 3, the Guardians of the Galaxy Holiday Special, et cetera, et cetera, et cetera. All of these things are listed here. Okay, so the coolest thing that you can do with rvest is you can create an automated browser. You can create an HTML session, okay, which is different from just reading in the HTML. An HTML session is like opening a browser window where you can then click links, okay? So here, I'm going to create a session starting on the Lego Movie page. Starting at the Lego Movie page, I'm going to create a session, okay? So I say HTML session. I'm going to store this as S. This is going to create my HTML session. And so inside R, this is a large rvest session. And what we're going to do is we're going to say, starting at that session, follow the link that says Chris Pratt. Okay, and if I do that, then it's going to find the first I guess it should just say session. Okay, starting there, we're going to follow the link that says Chris Pratt. Okay, and it's going to navigate to that page. Okay, it's going to navigate to that page. And we're going to say read in the HTML. And once we read in the HTML, then we can say go extract the nodes and extract the text. Okay, so here I'm going to create a loop that's going to do this. So I have my session. We are going to remember in cast, I've got the names of all of these actors. It's going to find the link that has Chris Pratt. Then it's going to find the link that says Will Ferrell. Then it's going to find the link that says Elizabeth Banks and Will Arnett. And I'm going to just do this for the first 4 links. Okay, so we're going to say cast 1 through 4. We're just going to do it for these 4 actors. And we're going to say start at the session at the Lego Movie page and follow the link with the name Chris Pratt. And then at the next iteration, actor name will be Will Ferrell. Follow the link with the name Will Ferrell. And the next loop iteration will be Elizabeth Banks. Follow the link with the name Elizabeth Banks. Read in that HTML, store that as the actor page. Within the actor page, read in the HTML nodes, BA, extract out the text, and just give me the first 10. We're going to do the same thing. I've also given used Selector Gadget to find the tag for figuring out the year of their projects, and we're going to pull that out. Okay, and then I'm also going to just kind of repeat this, and all of this is going to get stored in a big list. And you know, make sure you read this code, but it's browsing the internet to all of these different pages, and it's extracting the information I'm asking for it. Okay, and so if I take a look at this, I've got this big list. Okay, it's a list of 4. Okay, 4 train cars. Okay, a train car for Chris Pratt. Within Chris Pratt's train car is a train car with 3 things: movies, years, name. Okay, I got a train car for Will Ferrell, and within that there's a list, a train, you know, movies, years, name. And then I've got another list element, Elizabeth Banks, and inside there's another list. So it's a list nested inside a list. And so to kind of clean that up, I'm going to go through each of these things, append them together using this. Oops. And then so now I can arrange all of my stuff in a big data frame. And I have basically, the 10 most current projects of each of these 4 actors. So here are the 10 most current projects for Chris Pratt. Here are the 10 most current projects for Will Ferrell. Here are the 10 most current projects for Elizabeth Banks. Here are the 10 most current projects for Will Arnett. Okay, and this was all done by creating an automated browser session that allows us to kind of start on a web page, visit other links, and then once we're at the other, follow the link to a new page, we can extract the information from that new page. This script is posted online on Canvas, and you should be able to kind of follow along and hopefully understand what's happening. Okay, that is it for today. We'll go ahead and end here. Have a good rest of your day, and we will see you guys on Friday.